Hello, everyone, and welcome. Today we have GraphRAG for Law, building legal reasoning agents with Neo4j and LLMs. And today we have Aleksandr Khazov, and we'll hand it over to him.
Hello, everyone. Thank you for joining this session. And I will definitely explain how to structure the law using Neo4j and use it for LLMs to get the consistently traceable and explainable results. I have 20 years of experience as a practicing lawyer and 10 years as the legal tech developer and two degrees in that field. So I combine my knowledge to deliver those kind of products using my law practice experience to structure the software properly to deliver precise results. So why should we use GraphRAG for structuring the law? The problem is that regular raw LLM is not good for answering legal questions. Why? Because even though LLMs may be very self-confident, but they are not regularly produce traceable results. Why? Because hallucinations may be caused by static training data, outdated law, no access to private or corporate by default, and classic RAG helps to retrieve passages and relationships, connect statutes and precedents into graphs, showing how provisions relate. On paragraphs, regularly represent one nodes, which eliminates the problem of the chunking, and the hybrid retrieval allows us to get the not only vector results but also graph traversal and classification nodes, as we will see later. Our plan for this session is to explore how to model legal entities and relationships as a graph, augment those graph layer with vector and classification layers, and assemble 3D context to construct comprehensive context for the LLMs. If we will have time, I will represent live demo at our website and answer some questions. So first, let me introduce the two general patterns in constructing GraphRAGs. One of those, as we believe, is the graph on ephemeral graph on the fly, and the other is pre-built. Those are two patterns are different in their purpose, because first of all, on the fly, GraphRAGs allows for quicker results when using smaller set of documents, and pre-built graph allows us to invest upfront to construct the full corpus of model, like full base of legislation and so on. Let me stop a little bit more in details on that session, on that slide, to better explain the advantages and disadvantages of each type of GraphRAG build. First of all, on-the-fly GraphRAGs can be very quick to compose. They're perfect to answer ad hoc quick questions. They are very good in when you have a need to make the proof of concept and so on. But their lack of base knowledge they can be very APOC in matter of data structures and so on. Pre-built graphs, on the other hand, allows us to construct the whole corpus of legislation and demand very massive investments in constructing data model, in pre-elaborating texts of legislation, extracting concepts, extracting references, which is most important for constructing not only vertical hierarchical references, but also horizontal edges to build the full scale graph. And but these investments pays off because you are getting auditable provenance. You can perform deep classification, extracting super consistent and super valuable knowledge from those nodes, which is in most cases impossible when you do some works on the fly. Sorry. So another issue is that the better approach is to use hybrid bridge, combining those two approaches. When you have predefined data model, ontologies use metagraph as the structure to map existing knowledge, pre-built legislative corpus to get the solid base, construct the update pipeline, and on top of that, construct the on-the-fly user documents pipeline, which allows to elaborate user docs, extract knowledge from those documents, map those knowledge against existing data model, and throw it against existing legislative corpus. That approach would bring us to absolutely amazing results when you can not only extract knowledge from user documents, but also compare those documents with the existing legislative corpus, and which we called it make early case assessments, when you can compare expectations of the client, of a lawyer, concerning their particular situation, with the existing case law, for example. So that gives us a very promising results, and we are now working on constructing both of those structures and trying to implement this hybrid bridge. So the next topic would be data models and how we structure the law in our solution. We opt out for using ontologies, and one of those are FIBR, which is functional requirements for bibliographic records, is the very well-known ontology enacted also in the European Union as the core for EuroLex knowledge graph. It explores a chain of instances. The root instance is work. The second is expression, and there are two others which we're not focused on right now. The work represents intellectual work. So it's any law, any case law, any document itself represents this work. It is represented by the work. We now you can see the simple graph representing one act, and expression represents its a version, one of versions, one of the ways legislator or judge expresses its this work. So this is the very convenient way to work with versioning. When you have pretty dynamic legislation. It's not the case for the legal precedents, for court decisions, but with the acts, with the subsidiary legislation, it's really matters, because when you throw to LLM context with the case law dated 15 years ago and contemporary act, it definitely will lead to some hallucinations, because act might be changed for that 15 years. And so when you feed to LLM parts of case law texts, you should compare those texts or accompany those texts with the contemporary for that particular decision, acts, subsidiary legislation, and any other sources. In that regard, we're using what we call matter expression and regular expressions. Here you can see that this expression is the current version of this act, and the others are just outdated versions, and the digits here represent the dates in this epoch. So the other interesting concept we use with modeling law in our graph is the Akomantosa ontology or XML standard, which is also developed by Bologna University for being used in European legislative practices. Actually, it's a very important step in developing legal tech in general, because it allows us to make markdowns inside legal texts. So this is one part of Akomantosa represents hierarchy, where each particular document is being represented by different structures, because, as you may understand, the case law, the decision of the court cannot have the same structure as the law or as the subsidiary legislation. So they have basically different sections, different blocks of texts, and so on. For example, the judge explains background of the case, arguments of the parties, and the legislators usually follow their strict hierarchy and strict schema to connect provisions. So each of those structures can be found in Akomantosa, and we inspired by that ontology implemented that in our data model. So you can see here those big green node is the act. This is smaller one is the subsidiary legislation. This is different work node. It is not a part of the hierarchy of the work of the act, but represents different work and different document, legislative document. Inside act, you may see parts as a first level, dividing the whole text of the act into bigger parts, and inside each part you may see sections and subsections. The interesting part here is that you may notice the cross-reference, because those are hierarchical edges. Each section has subsections and so on, representing particular texts. But here you have subsection which refers to another section. So let's say in that particular law, somewhere in that subsection, the legislator refers to the same text inside the document, and we represented this way. So we will explore how this can help in the retrieval part, but in general, this a common tosser is helping us to represent law as it is. The third layer, so there are actually 3 layers if we talk about constructing our graph. The first layer is the graph itself, and we use Fiber and a common torso to construct our data model and represent hierarchy of legal documents and collections of documents and their combinations. But the second level definitely is the vector representations of the text, and we use combined search, hybrid search by vector knowledge, by graph traversals, and also we implemented the classification layer, which helps us a lot to define which text particularly we should search in our database to extract context more precisely. We defined concepts, topics, and functional graphs, as I call it. Most of those concepts and topics were extracted by LLM classification, with concept and topics being in enumerated type, and functional object being the generated text basing on the source of the node. So we here follow the rule of constructing the graph, subject, predicate, object, with the text of each paragraph being the subject, the functional role being the predicate, and the functional object being the real object, real matter which this role is aimed to. So in other words, we represent another layer when you can have for example enabling clause or definition clause, or represent any other role which particular paragraph may act as in the text of the decision, of the court decision or the legislative act, and so on. This is how it defines in our database. So you can see concept being, for example, delegated legislation, topic family law. This functional role represents here enabling clause, and the functional object is a express an enabling clause, minister's authority to amend the schedule via gazette order. So this enabling clause is the role performed by that particular piece of text, which is represented by the node, and the functional object stored in the age, in the properties of the age, represents to which object this role is being applied. This is how it looks like in our interface when you extract knowledge from the knowledge graph. We defined several frames. Here you can see the case law representing 4 nodes. Each node has issue identification. It has a functional role, has topics, concepts, and functional object, as well as content itself, for sure. So how it helps us to define, to extract the context. First of all, direct text to cipher retrieval is very helpful when you need to extract particular this text of the decision or particular paragraph or particular provision of the act. This also helps us to extract knowledge using classification layer. For example, if you need to extract some definition, you may opt out using text-to-cipher procedure, avoiding any vector search. So it's very fast and points you directly to existing classification layer nodes. Moreover, if you may apply multiple search strategy. For example, if you need to extract all the arguments of parties in case law related to drug trafficking, you may extract these applying those filters also pretty easily, as Cipher queries allows us to do that, because we, as I said, have those concepts, have these topics and functional roles connected to every paragraph it may be relevant to. So if you're searching for a particular concept, you will get not only one particular node, but also other nodes which are not directly mentioned in the vector search or in semantic parts of the graph and so on. So this is the use of classification layer. As I said, you may see here that in those classification layer nodes, we have also embeddings, which allows us to make indexing and search on those objects. So in other words, if I'm searching something related to family law, I shouldn't have to. I don't necessarily have to use family law to construct the Cipher query, but may use different approaches to wording, and that provides super flexibility in when extracting knowledge from classification layer. For sure, vectors find semantic candidates and provide those to LLM context, and those three layers can work independently. Where if you wanna grab some particular paragraph of particular decision, you go and use direct cipher. If you wanna extract some knowledge, some definitions or any kind of classifications, you may use both direct cipher on classification layer and vector search on classification layer. Or you may use classical LLM approach, extracting knowledge from semantic layer using vector search. But combining those together allows us to get very flexible results and make double check on the consistency of the context providing to the LLM. For sure, graph traversal expands the neighborhood. That is important because at some points it's not only the particular paragraph found as a semantic candidate. It does not explain in details the whole semantic, especially if it refers to other paragraph or other text provision, other law provision, and so on. So, in other words, if the judge mentions some decision or statutes or or precedence in its text, this particular paragraph cannot only be the sole text provided to LLM. It should be accompanied by its neighborhood, and especially those texts and paragraphs and status referenced in that initial semantic candidate. This is definitely how lawyers work when they define the applicable law, when they found some important provisions or usable text in the court decision. They reference to another status or provision. They definitely should go and see what's saying in that particular piece of text referenced. So it allows us also to calculate missing events when you can extract what was not covered by the context, or extract some knowledge from some insights from a user query, which can be missing. For example, if the user provides information about his case, he may not be providing some important details. And using data model and those combined approach, we may extract and define which information is missing. And also all this is a very human in the loop and React friendly. We can interrupt the proceeding at any time, suggest user to coordinate the next actions, and or using all those free layers as tools in React agents. So here's the big picture of how two case law node can be connected to each other, comparing with the Act. So I will briefly leave it here, and will allow to ask some questions if you have. Please feel free. I see. Yes, I see the question asking me, can you have record scoring based on numbers of entities or another logic? For sure, we arrange results as here's the example of how the contacts look like. You may see the question and the answer of particular for example, this way. Here's the question and the answer, and this one is context, and this one beautiful is the graph we constructed out of those nodes. So as you can see, we have here all the extracted nodes with with the functional rows, legal topics, and so on. And each paragraph is represented by the simplified content, and so on. Also, we have some acts may refers to, and those links also refer to particular nodes in the graph. So that's in general the whole picture of how this service works. Please provide the questions if you have it. Yes, there's some drawbacks here, and I didn't explain it. Probably not drawbacks, but some, let's say, problems, challenges on the way we should focus on. We may take a look at those closely. Those that can be, first of all, the problems with classification. It cannot be for sure guaranteed that classification is correct. The other is the different formats of documents used by the by users or different models of legislation. That is particular problem where EuroLex, European Publishing Office, struggling applying the a common torso and developing their knowledge graph, because as you may know, the legislative field of European Union is very fractured. It consists of 27 countries, and each country has its local legislation, its local rules, its tradition, language, and so on. And on top of that exists the layer of legislative layer of and litigation layer of European Union. So combining all this together is pretty challenging, and applying exact knowledge graphs to those fragmented pieces of legislation is super inconvenient. So that is one of the major problems here. Others, there are actually many problems here we are tackling. The other is extracting references, because judges in their decisions always, or in most cases, use like anchors, saying that this act referencing to another act or another court decision, mentioning that first time in their text, and then using some abbreviation or some reference to that anchor, place it in the beginning of the text, and if you take particular text of the paragraph and try to extract the reference to that anchor, it's pretty difficult to perform. You have to insert some temporary anchor to get the correct reference. So many problems, but the solution is very promising, because we saw how convenient and how flexible is the extraction workflow, and we see the real results in benchmarking with the existing assistance, and use for our retrieval parts for different workflows, like combining the knowledge, or combining the context for particular query. So good question, how many times you deleted your database before you get it right? Actually, we never delete it. We just make it right one time, and but we roll back several times to the eliminating the made progress. So I guess we don't have much questions. We may end the session. If anybody has any other question, that's the last chance to ask. We benchmarking on each stage of major step towards the. There's a question on benchmarking post creation. or on the fly. Yes, we are making since we got the working zero version of the database and retrieval part. We try to extract and compare the results with other assistants, and it allows us to compare the results.
All right. Thank you so much for all your questions. We are at time, and we encourage everyone to attend their next session. Thank you so much for joining.
So we can hear you. Okay.
Just jumping in, Alex over here. I think there's some network issue with Salah. Thank you so much for your talk. We'll be ending this one. Thanks a lot, and we'll be on to the next.
Okay, bye.
All right, take care.